Hello, and welcome to Space to Sleep. At this very moment as you settle into rest, something silent is happening about 300 miles above your head. It makes no sound. It emits no light visible to the naked eye on most nights. But it is there, moving at 17,000 miles per hour, completing one full orbit around the planet every 90 minutes. And it is not alone. There are more than 10,000 of them. 10,000 small metallic objects, each roughly the size of a dining table, orbiting the Earth in overlapping layers, forming a technological web that wraps around the planet like a second skin, thin and invisible. This network did not exist 10 years ago. 20 years ago, the idea of placing thousands of satellites working in synchrony would have seemed like science fiction exaggeration. And yet, in 2025, it is there, functioning, transmitting data, connecting remote villages in the Alaskan interior to hospitals in Tokyo, allowing fishermen in the middle of the Pacific to send messages to their families on solid ground, bringing internet to regions where cables never arrived and probably never will. All of this happens in silence without most people even realizing that when they look at the night sky, they are looking through a mesh of human technology that is now a permanent part of the orbital landscape. The curious thing is that you do not need to understand how this works to be affected by it. The presence of this network changes something subtle in our relationship with space. Throughout all of human history, the sky was an untouched place, distant, empty, reserved for stars, planets, and the occasional comet. Now, for the first time, there is an artificial layer between us and the cosmos. A layer that we built. A layer that reflects in a quiet way how much the human species has expanded beyond the surface of its own planet. And perhaps there is something strangely comforting in this. Not in the sense of conquest or domination, but in the sense of continuity. That while you close your eyes and let your body relax, there is a structure up there, created by human hands, maintained by engineers on the ground, powered by solar panels that capture light from the same sun that warmed ancient civilizations. And this structure keeps functioning, silent, constant, orbiting while you sleep. There is a detail about how this network formed, about the years of launches and orbital adjustments, that we can explore calmly throughout this night. The story of how 10,000 satellites came to orbit the Earth did not begin with a single spectacular launch. It began with repetition, with consistency, with rockets ascending week after week, month after month, each one carrying dozens of compact units that were released in sequence, like seeds being scattered across an orbital field. Most of these launches happened without major media coverage. They became routine, and it is precisely this routine that reveals something profound about the technological moment we are living in. Access to space has stopped being an event and has become a process. The satellites that form this constellation operate in low Earth orbit, at an average altitude between 300 and 400 miles above the surface. This proximity to Earth is intentional. The closer the satellite is, the less time a signal takes to travel back and forth. This means less delay in communications, which allows for more stable video calls, more responsive connections, an internet that works almost as if the cables were buried in the ground, even when there is no ground nearby. Only ocean, forest, desert, or ice. Each satellite weighs just over 500 pounds. It carries antennas, processors, orientation systems, and solar panels that unfold like wings after launch. They do not stay still. They are constantly adjusting their positions, avoiding collisions, responding to commands sent from ground stations scattered around the world. It is an orbital choreography that happens in real time, 24 hours a day, every day of the year. And while this technological dance unfolds in space, down here, ordinary people simply use the internet. They send emails, they watch videos, they make calls. Most do not even know that the data is passing through space. And perhaps this is the clearest sign that the technology has matured, when it becomes invisible, when it stops being a novelty and becomes infrastructure. This invisibility, however, does not mean absence. The satellites are there. The network is functioning. And tonight, as you rest, we can journey together through the details of this silent presence, understanding not only how it works, but what it means for human history to have built a second layer around our own planet. Before we continue deeper into this nighttime exploration of the satellites quietly circling above us, I want to take a moment to say how glad I am that you are here. These journeys through science and space are created for moments exactly like this one, when you want something calm and meaningful to accompany you as you drift towards sleep. If you find this kind of content helpful, if it brings you a sense of peace or curiosity as you relax, consider subscribing to the channel, sharing this with someone who might need it, or simply returning on another night when sleep feels distant and you need a gentle voice to guide you through the wonders of the universe. This is what these videos are for, to be here whenever you need them, like a quiet companion in the dark. Now, let us continue. If you were to rise straight up from where you are lying right now, passing through the atmosphere, leaving behind the clouds and the thin blue line that marks the edge of breathable air, you would eventually reach a region of space that is no longer empty. Not in the way it was for most of human history. Not in the way your grandparents would have imagined it. Somewhere around 300 miles up, you would begin to encounter them. Small, flat, reflective objects moving in disciplined paths. Each one a node in a network so vast that it takes a particular kind of map to even visualize it properly. These satellites do not cluster together. They are distributed across multiple orbital planes, which you can think of as invisible highways circling the Earth at slightly different angles. Some planes are tilted more toward the poles, allowing coverage over northern Alaska, Greenland, and Antarctica. Others are closer to the equator, serving tropical regions and the vast stretches of ocean where most of humanity never ventures, but where ships and aircraft still need connectivity. The result is a kind of three-dimensional lattice, a geometric structure that exists not on paper, but in the vacuum of space, held in place not by physical connections, but by the mathematics of orbital mechanics. Each satellite in this constellation travels in a carefully calculated path. The speed is not arbitrary. It is the precise velocity needed to balance the pull of Earth's gravity against the tendency to fly off into deeper space. Too slow, and the satellite would fall back toward the atmosphere, burning up in a streak of light. Too fast, and it would escape into a higher orbit or beyond. The sweet spot for low Earth orbit is roughly 17,000 miles per hour. At that speed, the satellite is perpetually falling toward the Earth, but also perpetually missing it, tracing an endless circle that, barring intervention, would continue for years. But these satellites are not left to drift passively. They carry small thrusters, usually powered by compressed krypton gas, which allow them to make fine adjustments to their trajectories. These adjustments are necessary for several reasons. First, even at 300 miles up, there are still traces of atmosphere, incredibly thin, but enough to create drag over time, slowly pulling satellites lower. Without occasional boosts, they would gradually descend and eventually burn up. Second, the sheer number of objects in orbit creates a crowded environment. Not just the satellites themselves, but defunct equipment, fragments from old missions, and the natural debris of decades of space exploration. Collision avoidance is a constant concern, and the satellites must sometimes shift their paths to dodge an approaching piece of space junk. The ground stations that communicate with this constellation are spread across the planet, in locations chosen for their geographic coverage and their ability to maintain line-of-sight contact as the satellites pass overhead. A satellite might be visible from a given ground station for only a few minutes before it moves beyond the horizon, replaced by another satellite rising from the opposite direction. The handoffs happen seamlessly, managed by software that tracks every satellite's position and predicts where it will be seconds, minutes, and hours into the future. What makes this system different from earlier satellite networks is the sheer redundancy built into its design. Older communication satellites often operated in geostationary orbit, about 22,000 miles above the equator, where they could remain fixed relative to a point on Earth's surface. These were large, expensive machines, and losing one could disrupt service for entire regions. The new approach is the opposite. Many small satellites, each one relatively inexpensive, each one replaceable. If one fails, the network routes around it. If it doesn't fail, the impact is barely noticeable. The system is designed to tolerate loss, to absorb failure, to keep functioning even as individual components reach the end of their operational lives. And those lives are not long by the standards of traditional satellites. A geostationary satellite might operate for 15 or 20 years. The satellites in this low Earth orbit constellation are designed for roughly 5 years of service, after which they are deliberately deorbited, guided back into the atmosphere to burn up safely, making room for newer, more capable replacements. This constant cycle of launch, operation, and disposal creates a kind of metabolism for the network, a continuous renewal that keeps the technology current and the orbital environment from becoming too cluttered with obsolete hardware. Lying here, breathing slowly, you might find it strange to think of this level of engineering complexity happening silently above you. No sound reaches the ground from those orbits, no vibration, no indication at all, unless you happen to catch a glimpse of the satellites passing in a line just after sunset or just before dawn, when the angle of the sun illuminates them against the darkening sky. In those moments, they appear as a string of moving lights, steady and unhurried, tracing a path that ancient observers would have found inexplicable. But even without seeing them, you are connected to them. If you have ever used the internet in a rural area, on a boat, in a remote cabin, or even on a flight crossing an ocean, there is a chance your data traveled through this network. The packets of information that make up a video call, an email, a simple search query. They rose from your device, reached an antenna, beamed up to one of those satellites, and then bounced back down to a ground station, perhaps thousands of miles away, all in less time than it takes to blink. The distance is vast, but the speed of light is vaster. The latency, the delay you might notice in a conversation, is measured in tens of milliseconds. Perceptible if you are looking for it, but small enough to feel like real-time communication. This architecture, this invisible shell of technology, represents something new in the human relationship with space. For most of history, space was a place we looked at. Then, for a few decades, it became a place we occasionally visited. Now, it is becoming a place we inhabit. Not with our bodies, but with our machines, our infrastructure, our continuous presence. The shell is thin, a few hundred miles of altitude in a universe billions of light years deep. But it is ours. We built it. We maintain it. And it keeps working, orbit after orbit, day after day, while you rest below. There is a particular kind of silence that belongs to things that work continuously without demanding attention. The silence of a beating heart. The silence of breath moving in and out of your lungs. The silence of blood circulating through vessels you never think about. These are processes so reliable, so constant, that they fade into the background of awareness, noticed only when something goes wrong. The satellite network circling the Earth has begun to acquire this same quality of silence. Not because it makes no electromagnetic noise, but because it has become infrastructure. And infrastructure, when it works, is invisible. Consider what happens when you send a message from a place with no cell towers, no fiber optic cables, no traditional means of connection. Perhaps you are on a research vessel in the Southern Ocean, surrounded by grey water and icebergs, thousands of miles from the nearest city. You type a message on your phone or computer. You press send, and within seconds, that message is received by someone on the other side of the planet. The process feels simple, almost trivial. But the journey those data packets took is anything but trivial. From your device, the signal travels to a small antenna mounted on the ship. A flat, electronically steered antenna that can track the satellites passing overhead without physically moving. This antenna sends your data upward as a beam of radio waves to a satellite that happens to be in view at that moment. The satellite receives the signal, processes it, and then does one of two things. It either transmits the data back down to a ground station within its line of sight, or, if no ground station is visible, it passes the data to another satellite using laser links. Beams of light connecting one satellite to the next, forming a relay chain that can span continents in milliseconds. These laser links are one of the quieter technological achievements of the constellation. Radio waves work well for communication between satellites and the ground, but between satellites themselves, lasers are superior. They can carry more data, they are harder to intercept, and they do not require the same regulatory coordination that radio frequencies demand. The satellites communicate with each other in a language of light, invisible and instantaneous, passing information from node to node until it reaches a satellite that can see a ground station and deliver the message to the terrestrial internet. The ground station receives the signal, routes it through fiber optic cables to the global internet backbone, and from there, the message travels to its destination. Another computer, another phone, another person. The entire process, from the moment you pressed send to the moment the message is delivered, takes less than a second. You do not see the satellites. You do not hear the lasers. You do not know which ground station handled your data or how many orbital handoffs occurred. You just know that the message arrived. This seamlessness is the result of decades of engineering refinement, countless hours of testing, and a continuous investment in maintaining and updating the network. But it is also the result of a philosophical shift in how we think about space systems. The old model of space infrastructure was heroic. Every launch was an event. Every satellite was a precious asset. Every mission was a story with a beginning, middle, and end. The new model is industrial. Launches are routine. Satellites are mass-produced. The system is designed not for individual brilliance, but for collective reliability. And yet, beneath this industrial routine, there is still something remarkable happening. Each satellite is a sophisticated machine, equipped with sensors, computers, thrusters, and communication systems that must work in the harsh environment of space. There is no atmosphere to protect them from radiation. There is no technician who can fly up and fix a broken component. The temperature swings are extreme. Hundreds of degrees hotter when facing the sun, hundreds of degrees colder in shadow. The satellites must be designed to survive these conditions autonomously, to diagnose their own problems, to adjust their own behavior, to continue functioning for years with no physical intervention. The engineers who design these machines work with a particular mindset, one focused on anticipating failure modes and building in redundancy. If a solar panel does not deploy correctly, there must be a backup plan. If a thruster becomes clogged, there must be an alternative. If a computer chip is damaged by a cosmic ray, the software must be able to recover. This mindset, applied across thousands of satellites, creates a network that is remarkably resilient, able to absorb failures, route around damage, and keep providing service even as individual components reach the end of their lives. Lying here, letting your muscles relax, you might notice how little you normally think about the systems that support your daily life. The electrical grid that powers your home, the water pipes that bring clean water to your faucet, the internet infrastructure that connects you to the world. These systems work in the background, silently, continuously, and we notice them only when they fail. The satellite network is becoming another one of these invisible supports. A layer of infrastructure so reliable that it fades from conscious awareness, present but unnoticed, like the air you breathe. There is something restful in this thought, the idea that while you sleep, systems are operating, connections are being maintained, data is flowing. You do not have to supervise any of it. You do not have to understand every detail. You can simply trust that the infrastructure will continue to function, that the satellites will keep orbiting, that the network will remain intact. And in that trust, there is a kind of permission to let go, to release the need for vigilance, to rest in the knowledge that the world will keep turning and the systems will keep running with or without your conscious attention. If you were to step outside on a clear night, away from city lights, and look up at the sky in the hour after sunset, you might see something that would have been impossible to see just a decade ago. A line of lights moving steadily across the darkness, evenly spaced, neither blinking like aircraft nor stationary like stars. These are the satellites, caught in the geometry of twilight, still illuminated by a sun that has already set from your perspective on the ground. They move in procession, silent and orderly, before fading into the Earth's shadow and disappearing from view. This sight has become known informally as a satellite train, and in the early years of the constellations' deployment, it caused both wonder and concern. Wonder because it was genuinely novel, a visible sign of human activity in space that anyone could observe without a telescope. Concern, because astronomers worried about the impact on their observations, about the streaks these satellites might leave across long-exposure images, about the potential loss of pristine dark skies that humanity had always taken for granted. The company responsible for the constellation responded to these concerns with a series of modifications. They applied special coatings to reduce the satellite's reflectivity. They adjusted the orientation of the solar panels during certain phases of orbit to minimize the sunlight they reflect toward Earth. They worked with astronomical organizations to coordinate observation schedules, to identify windows of time when the satellites would be in shadow and therefore invisible. These efforts have reduced the visual impact, though they have not eliminated it entirely. The satellites are still there, and under the right conditions they can still be seen. But perhaps the more interesting question is not whether we can see the satellites, but what it means that they are there to be seen. For the first time in history, the night sky includes a permanent human presence. Not a single bright point like the International Space Station, but a distributed network, a mesh, a pattern that will only grow denser as more satellites are launched. This changes the sky from a purely natural phenomenon into something partially constructed, partially engineered, partially ours. Some people find this troubling. There is a loss involved, they argue, a loss of wilderness, of untouched nature, of the ancient human experience of looking up at a sky that contained nothing human. That sky connected us to our ancestors, to the cave painters who saw the same stars, to the navigators who used those stars to cross oceans, to every generation that has ever looked up and wondered. The introduction of human artifacts into that view changes the experience in ways that cannot be undone. Others find it remarkable. The sky has always changed, they point out. It was not the same for the dinosaurs as it is for us. Continental drift has shifted the view from different latitudes. The slow wobble of Earth's axis has moved the pole star over millennia. The sky has never been static, and the addition of satellites is simply the latest change, one that reflects not natural processes, but human ambition, human creativity, human reach. To see those lights moving overhead is to see evidence that our species has become capable of building things that exist beyond the surface of our planet, that our influence now extends into the space between worlds. Both perspectives contain truth. Both are worth holding as you lie here, breathing slowly, perhaps looking through a window at the sky outside, or simply imagining it behind your closed eyelids. The sky you imagine might be the ancient sky, filled only with stars and planets, the same sky that Galileo turned his telescope toward. Or it might be the modern sky, with its invisible mesh of satellites, its thin layer of human technology. Or it might be both at once, the ancient wonder layered with the new, neither erasing the other, both present in the same upward glance. From the perspective of the satellites themselves, if we can imagine such a perspective, the view is entirely different. They look down, not up. Below them, the Earth curves away in all directions, a sphere of blue and green and brown, wrapped in white clouds, glowing with city lights on the night side. The satellites do not experience sunrise and sunset the way we do. They orbit so fast that they see the sun rise and set 16 times in a single Earth day. The boundary between light and shadow sweeps across the planet below them like a slow wave, and they ride above it, sometimes in sunlight, sometimes in darkness, watching the planet turn. From that altitude, the concerns of individual humans are invisible. You cannot see a person from 300 miles up. You cannot see a house or a car or a road unless you know exactly where to look. What you can see are patterns, the glow of cities, the dark patches of forests and deserts, the branching networks of rivers catching the light. The Earth from above is a world of systems, of flows, of processes too large for any individual to perceive from the surface. The satellites are part of those systems now, nodes in a network that spans the planet, participants in the continuous flow of information that connects billions of people. And perhaps there is something comforting in that larger view. From the perspective of a single human life, problems can feel overwhelming, urgent, all-consuming. But from 300 miles up, those problems are invisible. What remains visible is the planet itself. Beautiful, resilient, still mostly wild, still mostly ocean and forest and ice. The satellites do not judge. They do not worry. They simply orbit, transmit, receive, and continue. They are machines without anxiety, performing their functions in the silence of space. And you, resting below, can borrow a little of that silence, a little of that perspective, as you let the concerns of the day fade and the quiet of night settle around you. The construction of the satellite network did not happen in a single dramatic moment. There was no equivalent of the moon landing, no single event that captured the world's attention and marked a clear before and after. Instead, the network grew gradually, launch by launch, over the course of years. Each launch added a few dozen more satellites. Each batch extended the coverage a little further, filled in a few more gaps, improved the overall capacity. The progress was incremental, almost invisible, and yet the cumulative result is something that would have astonished the engineers of an earlier generation. The rockets that carry these satellites into orbit are themselves a remarkable achievement. They are designed to be reusable, which means that after delivering their payload to space, they return to Earth and land, sometimes on drone ships floating in the ocean, sometimes on concrete pads near the launch site. This reusability was not possible until relatively recently. For most of the space age, rockets were expendable. You built them, you launched them, and they fell into the ocean or burned up on re-entry. Each launch required a brand new rocket, which made access to space expensive and limited. The development of reusable rockets changed the economics of space. A rocket that can be flown again and again, like an airplane, costs far less per launch than one that is thrown away after a single use. This cost reduction made it feasible to launch thousands of satellites, to build a network that would have been financially impossible under the old model. The rockets became workhorses, flying again and again, their sooty exteriors marking them as veterans of multiple journeys to the edge of space. The satellites themselves are manufactured in a facility that operates more like an automotive assembly line than a traditional aerospace workshop. They are produced in batches with standardized components, rigorous quality control, and a pace of production that would have been unthinkable in the early days of the space age. A single satellite might take only a few days to assemble, test, and prepare for launch. The factory runs continuously, turning out new units to replace those that have reached the end of their operational life, or to expand the constellation further. This industrialization of satellite production represents a fundamental shift in how humanity relates to space. Space is no longer the exclusive domain of governments and a handful of aerospace giants. It has become accessible to private companies, to entrepreneurs, to organizations with ambitious visions and the capital to pursue them. The barrier to entry is still high, but it is lower than it has ever been, and it continues to fall as technology improves and experience accumulates. The people who work on this network, the engineers, the technicians, the software developers, the launch crews, number in the thousands. They are scattered across multiple countries, working in offices and factories and launch sites, connected by the same digital infrastructure that the satellites themselves provide. Many of them will never see a satellite up close. Their work is done through screens, through simulations, through the abstract language of code and equations, but the result of their work is tangible, physical, real. Thousands of machines circling the planet, transmitting data, connecting people, functioning as designed. There is something quietly heroic about this kind of work. It does not make headlines. It does not produce celebrity astronauts or dramatic mission patches. But it represents a sustained effort, a collective achievement, a willingness to show up day after day and contribute to something larger than any individual. The network exists because thousands of people decided that it should exist and then did the work to make it real. That work continues. New satellites are being built right now. New launches are being planned. The network is not a finished project, but an ongoing one. A living system that requires constant attention and effort to maintain. As you lie here, feeling the weight of your body against the bed, you might appreciate this kind of steady, quiet effort. Not every achievement is dramatic. Not every contribution is visible. Sometimes the most important work is the work that simply continues, day after day, without fanfare, without recognition, building something that will outlast any individual involved in its creation. The satellite network is like that. It will still be there tomorrow and next month and next year, because people are working right now to make sure it remains. And that continuity, that reliability, that ongoing commitment to keeping the system running. There is a kind of peace in knowing that such efforts exist, that not everything depends on you, that some things will keep functioning while you rest. Throughout human history, the things we have placed in the sky have carried meaning beyond their practical function. The first artificial satellites, launched in the middle of the 20th century, were symbols of national power, of technological achievement, of the rivalry between superpowers. They beeped their radio signals into the void, and people around the world listened, understanding that something fundamental had changed. Humanity had placed an object in orbit. The sky was no longer unreachable. The satellites circling the Earth today carry a different kind of meaning. They are not symbols of rivalry, but of connectivity. They exist not to demonstrate power, but to provide service, to solve the practical problem of bringing communication to places where wires cannot reach. Their meaning is utilitarian, mundane, almost boring. And yet, there is something profound in that mundanity. It represents a maturation, a transition from space as spectacle to space as infrastructure, from extraordinary events to ordinary operations. This transition mirrors other technological transitions in human history. The first railroads were objects of wonder, symbols of progress, subjects of poetry and painting. People travelled miles just to see a train pass by. Within a few generations, trains had become ordinary, part of the background of daily life, no more remarkable than roads or bridges. The same happened with airplanes, with automobiles, with telephones, with computers. Each technology began as a marvel and ended as a tool, its wonder fading as its usefulness became routine. The satellite network is following the same path. The early launches were covered by media, discussed by enthusiasts, debated by critics. Now, they happen almost weekly, and most people do not notice. The network has become part of the infrastructure of modern life, as invisible as the electrical grid, as taken for granted as running water. This is not a failure of imagination, but a success of integration. Technology becomes truly useful when it stops being exciting, when it simply works, when it fades into the background and lets people focus on what they want to do, rather than on the tools they are using. But invisibility is not the same as unimportance. The electrical grid is invisible until it fails, and then its importance becomes painfully clear. The same is true for the satellite network. Most people do not think about it, but many people depend on it, not just for convenience, but for safety, for livelihood, for connection to the wider world. A fishing boat in distress in the middle of the ocean can call for help because of these satellites. A scientist in Antarctica can share data with colleagues in real time. A family in a remote village can video call relatives who emigrated to distant cities. These are not trivial uses. They are threads in the fabric of human connection, enabled by machines that orbit silently overhead. The presence of this network also changes the meaning of remoteness. Throughout history, remote places were defined by their distance from centers of communication, from roads, from telegraph lines, from cell towers. To be remote was to be cut off, isolated, out of reach. The satellite network begins to dissolve that equation. Remoteness becomes geographic rather than communicative. You can be in the middle of the Sahara, the Amazon, the Arctic, and still be connected, still be part of the global flow of information. The physical distance remains, but the communicative distance shrinks towards zero. This has consequences that are still being understood. Remote communities gain access to information, education, markets, services that were previously unavailable, but they also become exposed to influences they might not have chosen, to content and values from far away, to the homogenizing forces of global connectivity. The network is neutral in this regard. It carries whatever signals people choose to send. The consequences depend on choices made by humans, not by the machines. Lying here in the quiet, you might reflect on your own relationship with connectivity. There are times when being connected feels like a burden, when the constant availability of information becomes overwhelming, when the demands of digital life crowd out space for rest and reflection. And there are times when connection feels like a gift, when it allows you to reach people you love, to learn things you want to know, to participate in conversations that matter to you. The network does not determine which of these experiences you have. It simply provides the possibility, the infrastructure, the silent support that makes both possible. And perhaps that is the most honest way to think about the satellites overhead. They are not inherently good or bad. They are tools, infrastructure, a layer of capability that humanity has added to the world. What we do with that capability is up to us. The network will keep orbiting, keep transmitting, keep connecting. The meaning of that connection, whether it enriches or depletes, whether it brings us together or pulls us apart, depends on choices made down here, on the ground, by people living their lives, trying to figure out how to use the tools they have been given. Tonight at least, the network is quiet. The satellites are passing overhead in their endless circuits, but you do not need to think about them. You do not need to check your messages or respond to notifications or stay connected to anything at all. You can simply be here, in this room, in this bed, in this moment, letting the technology fade into the background where it belongs. The network will still be there in the morning. The satellites will still be orbiting. And you will have rested, restored, ready to re-engage with a world that will keep turning whether you are watching or not. And so we arrive at the end of this journey, though perhaps arrival is not the right word. The satellites have not arrived anywhere. They are still moving, still orbiting, still tracing their endless paths around the planet. And you haven't arrived at a conclusion, because there is no conclusion to reach. There is only this moment, this breath, this quiet awareness that something new exists in the sky, something that did not exist a generation ago, something that reflects the restless ingenuity of a species that has never been content to stay within the boundaries it was born into. More than 10,000 satellites circle the Earth tonight. They are silent. They are functional. They are unremarkable in the way that all successful infrastructure eventually becomes unremarkable. And yet, if you step back far enough, if you consider what they represent, there is something remarkable about them after all. They are evidence that humanity has begun to build beyond its home planet. Not in a dramatic, cinematic way, not with gleaming space stations and heroic astronauts, but in a quiet, industrial, almost invisible way. The kind of building that happens when a technology has matured, when the excitement has faded, when the real work of integration begins. You do not need to feel anything in particular about this. You do not need to be inspired or concerned, optimistic or worried. The satellites will continue to orbit regardless of how you feel about them. The network will continue to function. The data will continue to flow, and you will continue to live your life, connected or disconnected as you choose, using these tools or ignoring them, finding your own balance between the digital and the physical, the global and the local, the connected and the solitary. Tonight, you have chosen rest. You have chosen to lie down, to close your eyes, to let the day fall away and the night settle around you. And above you, unseen but present, the satellites keep their silent watch. They are not watching you, of course. They are not aware of you. They are machines doing what machines do, functioning according to their design. But there is something almost companionable about their presence. Something that says you are not alone on this planet, that humans have built things that extend beyond the surface, that the sky is no longer empty, but populated with evidence of what we can accomplish when we work together, year after year, launch after launch, orbit after orbit. Let that thought settle like a blanket. Let it comfort you, or simply let it pass through your mind without attachment. The night is quiet, the sky is full, and you are exactly where you need to be, resting beneath a canopy of stars and satellites, part of a world that keeps turning, keeps building, keeps reaching upward into the dark. Sleep well, sleep peacefully. And if you dream, Perhaps you will dream of lights moving across the sky, silent and steady, keeping their endless vigil while you rest below. Good night.